We are going to start with complex numbers. The first thing that we must know is that when dealing with complex numbers, there are two forms of complex numbers. So the first form is called rectangular form. Rectangular form. So a rectangular form would be your normal complex form, which will be written in this form: a plus bi. Now the a part represents your real number, and the b part represents your imaginary part. Your imaginary part, or your imaginary number. So this is your rectangular form. And then the next form is called the polar form. So your polar form is typically in these forms. First form is z is equals to r bracket cos theta plus I sin theta. Then the next form under polar form is z equals to r c theta. So this r is the same as that r, and then the c represents cos, the I is the imaginary number, and then the s is for sine. Your angle is still the theta, sin theta. Then the last form for your polar form is r, then your angle. R will be your modulus, we'll talk about that later, and then this part represents the angle theta. So we are making it shorter from this to that, and then from this we come to this. So any form is acceptable. So we call these forms polar forms. Okay, so now we are going to go to our questions for today. Now that we've gotten that out of the way, we are going to answer these questions. So now the first question here, it says you are given the complex number. You are given a complex number it's given as z is equals to 5 minus 5i. Remember we said for your rectangular form, typically you would have z is equals to a plus bi. We also said this is the real part, this is the imaginary part. This is the real part, the a. The b represents the imaginary part. So it means if you are given this complex, before you even answer the question, you say this is the real part and this is the imaginary part. And remember, the imaginary part is not the 5, it's the negative 5. So the imaginary part would be the negative 5, not the 5. Okay, so the first question says, write down the quadrant in the complex plane in which z lies. You need to write down the quadrant where this complex number lies in the complex plane. So here's our complex plane. Our complex plane represents, or rather, it contains your imaginary plane as well as your real plane. And now we like to say RE instead of real, just to shorten it. So now 5 is your real part. It means you're going to count 5 units to the right because it's positive 5. So let's say 5 is somewhere here. You're also going to count 5 units to the negative side of the imaginary part. So let's say 5 is somewhere here, negative 5 rather. So it means when these two meet, where they meet, we are going to have our complex represented as an arrow. We are going to get our complex. Our complex is 5 minus 5i, and that is how you represent your complex number in the Cartesian plane or in the complex plane. That is how you represent your complex number in the complex plane. We like to call this the Argand diagram. Same thing. So this was the first question, 3.3.1. 3.3.1, they wanted us to represent this in the complex plane. Because of space, I'll do 3.3.2 here. 3.3.2, they say we should express the complex number z in polar form. So when we started, we said typically your rectangular form, I just need space to write this. Your rectangular form, I'll just write rect. Your rectangular form, it is this form here, z equals to a plus bi. Now your polar form, you can write it like this: z is equals to r, and then let me shorten it, c for cos, I for imaginary, s for sine, then theta. This is your polar form. The other polar form, you could say z is equals to r for your radius or your modulus rather, and then the angle theta. That is your polar form. So we could choose any of the two. There's another one which is much longer, but because of space I'm not going to write it. I'll just use any of the two. So now I want to convert this rectangular form to the polar form. What do? I first need to figure out r, because I can see that there's no r here. So I need to figure out r. The I is already that I there. Then I also need to figure out my angle. So first things first, your r will be the square root of the real part plus imaginary part squared. So it's the square root of a squared plus b squared, and that is how you figure out your r. Your a in this case, it's 5, so you'll say 5 squared plus your imaginary part is negative 5. Let me extend that a bit. Negative 5 squared. And when you press that into your calculator, you get 25 and 25, which is 50. So you have the square root of 50. The square root of 50, when we simplify the square root of 50, we should get 2, let me see, the square root of 50 is 25 times 2, so that is 5 root 2. Yes, the square root of 50 is 5 root 2. So this, when it's simplified, it's actually 5 root 2. 5 root 2. This is the value of r. Now that we've figured out the value of r, we need to go ahead and find our theta. Remember, we are trying to get to this form. So we have gotten r, which leads us to the polar form. We now need to get theta. So to get theta, this is what you do. Theta is the arctan, tan with a -1, it's called arctan of b divided by a. It's not arctan a over b, it's b divided by a. Always divide b by a. Then you're going to go ahead and press that into your calculator. Let's see. Let us find arctan. Looks like I don't know. Guys, I can't see my calculator. I'm trying to locate my calculator here in my phone, on my phone. Where is this calculator? There we go. Can someone assist with this? The answer to this arctan. Can't locate my calculator for some reason. We have B. Our B is, where is B? Here's B. This is A, that is B. Remember, it's A plus BI. So this is A and that is B. So we need to find the arctan of B over A. And then because your B is negative, always put positive here. Put it as a positive value. So we have 5 over 5. Oh, this one is actually easy, lucky for me. So this is 5 over 5, which is 1. So which makes our angle to be 45. So the answer to arctan 5 over 5, B over A, remember B is negative 5, A is 5. So the answer to 5 over 5 is 1. The arctan of 1 is 45. But guys, remember, this is not the actual angle. This is called the reference angle. So this is the reference angle. This is the angle that is located in the first quadrant. This is the angle located in the first quadrant. But remember, our actual complex number has our complex number, which is represented on the complex plane, has rotated by some degrees. So the angle that we found is actually this piece here. This piece here. This is the angle that we have found, but it's not the true angle. This is not the true angle of the complex, because the complex does not rotate and does not rotate clockwise. It rotates anti-clockwise. So we need to figure out this whole angle, and that whole angle will be how much? Any idea? Any contributions? I'm also looking for engagement, guys. I need you guys to engage with me, because we are looking for this angle here, because the complex has rotated to the fourth quadrant. We need to figure out the angle of rotation, and the angle that we got here, the 45, is actually that angle there. So how do we figure out the angle of rotation of the complex? What would be your answer in that case? Anyone who's willing to assist with that angle. So this 45 here is called the reference angle. It's not the actual angle. So we write ref with this symbol representing angle. So this is the reference angle, because it's the angle that assists us to find the true angle, the actual angle. So then what would be the value of theta? So the value of theta, the angle, our true angle, is actually this has rotated by almost 360, because it's in this quadrant. It has rotated by almost 360. We say 360 minus 45. We say 360 minus 45, and that is how we get our reference angle. and that gives us 315 degrees, and hence why our answer in polar form becomes Z is equals to R. Our R is 5 root 2, and our angle is 315, right? 315 degrees, and that is our complex number in polar form. That is our complex number in polar form. That is our complex number in polar form. Just to recap quickly, the first question, we're given this this complex number Z equals to 5 minus 5i, and then we said, the first question rather said we should represent this complex number in a complex plane. A complex plane is your normal Cartesian plane, but instead of f, y, and x, you say imaginary real. The imaginary part is the minus 5, the real part is the 5. So a and bi, a, bi, real, imaginary, real, imaginary. So the real part is 5. We put 5 here because it's positive 5. The imaginary part is negative 5. We go to the negative side of the imaginary line, go to minus 5. And then what is the next step? We simply connect the two coordinates or ordinates, minus 5 and 5. We get a point there, then we draw our line which represents our complex number. So that line must be accompanied by a direction. So there's a point here, but this line is actually an arrow. That is actually an arrow. That is our complex number represented on a complex plane. That was the first question. Now the second question said the very same complex number that's given, we must represent it in polar form. So it is given to us in rectangular form, and we need to convert this rectangular form to polar form. That is exactly what we did here. So rectangular form says to you, you have a plus bi, that is rectangular. Then polar form says the very same z will be r cos theta, or you could say z is r the angle theta. And that is what I wrote here. That is what we got here. So the first thing to do is to find r, which is your radius, which is the length of this line, sometimes called the modulus. So r is the length of this line, and then c represents cos, I represents imaginary, S represents sine, then theta, which is your angle. So we looked for R by using Pythagoras. So your Pythagoras in this case says you square A, you square B. So you square the sum of A and B, A squared plus B squared under the square root. Then you substitute your A and your B, which are 5 and minus 5. That's exactly what we did here. We got our R, which is our radius. After getting your R, you now figure out your angle, because you need to come here. You need to figure out your angle theta. Your angle theta is found by using this formula. This formula will never change. You will always say B over A. So it's tan, arctan of B over A. And then your B, again, if you check here, your B is 5. Your B is actually negative 5, but because of the formula, we put positive 5. The rule is that you should always put positive 5, positive numbers rather, for your formula. The angle that you get is not the actual angle, it's the reference angle. And why is that? It's because you got 45, and 45 is here in this quadrant. But you got 45, which is in this quadrant, but your complex has rotated more than 45, way more than 45 actually. It has gone beyond the first quadrant, second, third. It has landed in the fourth quadrant. So your complex number is rotated to the fourth quadrant, which makes 45 to not be our answer. So now we call it the reference angle. So it means the actual answer for your angle will be 360 minus 45. And why are we saying 360? It's because this has rotated more than 90, more than 180, more than 270. It's going towards 360. So we have to reduce 360 by the 45. This 45 is the angle here. And that is why we got 315. And what was the reason for this theta and this r? It was for us to come to z being r angle theta. That was the whole purpose. And if you've done that, you would have answered the question. If you have done that, you would have answered the question. That is that. We are going to look at the last question, which is a bit lengthy, might need more space, so I'm going to remove this. We are going to do a question on simultaneous. We are going to cover a simultaneous question based on complex numbers. Okay. Okay, so this simultaneous question, it's actually not that long. It's about 4 marks. So yeah, it's about 4 marks, but I will need the space anyway. Zamazulu Nkosi, hello. Lentle Madonsela, Sister Boss, hello and welcome to my first ever live. Welcome to my first ever live video. I'll be serving you guys technical mathematics grade 12, and these sessions will be based on grade 12 technical maths, and they are for revision purposes, hence why I'm covering question papers. So they are for revision purposes. If you know anyone who's doing grade 12, refer them to my live. If you know anyone who's doing technical mathematics grade 12, please refer them to my live. I might be doing these. I'm yet to decide actually. So the plan is to cover term 1's work. So I might record probably twice a week. I will see. So now the next question, which is the final question, is based on solving simultaneously for m and n. So we have been given this equation. We are told that the question actually says solve for m and n if m is 3i into 2i minus 5 plus 7 minus an I. So this is what we are having. They want us to solve for m and n at the same time. They just gave us one equation, one long equation, and we have to solve for m and n. So the first thing that you do in mathematics, whenever you see brackets, it means multiplication, and that's exactly what you do. So I'll just rewrite this thing and move it here in the middle. M is equals to 3i into 2i minus 5 plus 7 minus ni. Like I said, bracket means multiplication, so I'll just multiply 3i by 2i. So these are i's, it means I'll have those are i's, so it means I'll have I squared. So 3 by 2 gives me 6, I by I is an I squared, and then 3 by 5 is 15, so I have minus 15, and then there's an I there, there's no I here, it means there's that I remains. And then I've broken my bracket, I write the rest, 7 minus ni. Okay, so the next step is to say, whenever I see an I squared under this topic, complex numbers, whenever I see an I squared under complex numbers represents a negative 1. So my I squared changes to a minus 1. And then I keep the rest. I just rewrite the rest of the stuff. And then from there I will multiply 6 by minus 1, that is minus 6. Then I have minus 15i plus 7 minus ni. And then what is the next step? Sneaky wormhole. The next step is to add like terms. So we are going to say minus 6 and 7, they are numbers, so they will combine. We have minus 6 plus 7, that is 1. So I have 1 minus 15i minus ni. So we are getting much closer to the answer. The aim is to simplify first, and then after simplifying we associate. So solving your complex numbers requires you to first simplify, then you associate. What do we mean by association? It means where there are i's, you keep them on one side. Where there are numbers, you move them to one side. So we are going to create two equations here. We are going to identify the terms that have no i's rather. The terms that have no i's. When I say i's, I'm referring to the I, this I here. So the m has no I, it means it's a real number. It's a real part of a complex number. The 1 is a number, it has no I, it means it belongs to the real part. The 15 has an I, it's imaginary. The n has an I, it's imaginary. So it simply means to us the m and the 1, the m and the 1 belong to each other. So m becomes 1. It also means that the 15i, why did I write 5i? The negative 15i belongs to the ni. The negative 15i belongs to the ni. Ne? Oh, forgot the negative. So the negative 15i belongs to the ni. And what is the next step? The next step is to solve here. The I and the I will cancel because they both have i's. So the i's will cancel. And if the i's cancel, the negatives can also cancel, because the aim is to get n. We are not solving for I, we are not solving for negative. We need to be left with n on one side. So the goal is to get rid of the negative and the I. So that's exactly what we are going to do. We are going to divide by the negative and the I. We are going to do the same thing this side. Divide by the negative and the I. The negative cancels negative, I cancels I. Negative cancels negative, I cancels I. And it simply means our n is 15. Sorry. And those are the solutions. N is 15 and m is 1. Okay, a quick recap. We are given this equation. The question says solve for m and n. If m is 3i into 2i minus 5 plus 7 minus ni. So this is a complex equation. By complex I mean belongs to this topic, complex numbers. So what do? Whenever you see a bracket, you multiply. That's exactly what we did here in this step. 3i and 2i is 6i squared. 3i and 5 is 15i. Then the next step is to say whenever there's an I squared is minus 1. And that's exactly what we did. I squared was replaced by minus 1. Then we have a minus 6. The next step was to simplify. Numbers will add to give us a 1. The imaginary parts will remain imaginary because these ones can't be added. It's a 15i and an ni. We can't add or subtract. Then the next step is to simply associate. We say m goes with 1 because they are real. They have no i's. So the ones that have an I, we equate them together. The ones that have no i's, we equate them together. The m goes with 1. That's why we said m equals to 1. The ni goes with the 15i, and that's exactly why we equated them. Minus 15i is equals to minus ni. Get rid of the negative and the I. We only want n. That's why we get rid of the negative and the I. And that is that. Which brings me to the end of the video. So this question is worth 4 marks. So yeah, this is worth 4 marks. And that is how you deal with a complex number equation. It's considered a simultaneous equation, by the way. Thank you guys for joining my first live, my experimental live. I hope, I don't even hope, I know that I will be consistent and serve you guys some more content. Like I said, if you know of any grade 12 student who does technical mathematics, kindly let them know that there's someone who does technical maths on TikTok. Tell them to give me a follow and be on the lookout. I'll be dropping content probably twice a week. I don't know, I'll check, but I'll make sure that I drop something every week. So today we did complex numbers. Tomorrow, not tomorrow, sorry, next week we are going to be doing logs and equations and some simplification. So stay tuned. Sharp.